Hey everyone, thanks for joining us. Roy and I are very excited to be here at the Data and AI Summit Europe today. But before we begin, let me show you something. So take a look at your data pipeline. Now back to me. Now back at your pipeline. Now back to me. Sadly, your pipeline isn't me. But if you migrate your Airflow-based Spark jobs to Kubernetes, you can boost your data pipeline like me. So you can save tens of thousands of dollars per month, gain visibility, and make your systems more robust. How exactly? This is the question we'll answer today. So now we can officially start. My name is Itai Yafe. I'm a principal solutions architect at Imply, and previously the big data tech lead for a group at Nielsen. With me today is Roy Tevet, who's a big data developer at Nielsen Identity and a Kubernetes evangelist. You can reach us both over LinkedIn and Twitter. So let's see what you learned today. So first, you learn how to easily migrate your Spark jobs to Kubernetes in order to reduce costs, gain visibility, and robustness. All that while using Airflow as your workflow management platform. So just a little bit about Nielsen. Nielsen is famously known for measuring the ratings, the TV ratings in the US and other countries. It's essentially a data and measurement company, which means we collect data from various sources. Nielsen Identity unifies many of those proprietary data sets in order to generate a holistic view of a consumer. Of course, all the data is anonymized, and essentially serves as a single source of truth of individuals and households. So a little bit about us in numbers, since we are a data company. So we have over 10 billion events coming into our Kafka cluster every day. To process the data, we launch 6,000 Spark nodes every day and ingest 60 terabytes a day into our data lake, which is AWS S3 based. All in all, we have a few petabytes in that data lake. And finally, we use Apache Druid as our OLAP database, and we ingest tens of terabytes of data into it. So all that massive infrastructure imposes challenges. And the main challenges are scalability, fault tolerance, and cost efficiency. So you can probably imagine that we have dozens of workflows running around the clock. Originally, we used AWS Data Pipeline for workflow management, but we also wanted better visibility of configuration workflow, better monitoring and statistics, and also the ability to share common configuration or code between workflows. So this is basically why we love Airflow, because Airflow met all those requirements and more. We've been using it in production for the last 2+ years with over 40 users across 4 groups. We run about 1,000 data pipelines every day, and data pipelines are called DAGs in Airflow. We have about 20 automatic deployments of that DAGs every day, and thanks to the fact that the Airflow is an open source project, we were able to make 6 contributions to it. So don't worry if you're not familiar with Airflow. This is just a way in Airflow to visualize your data pipeline. So if we take a closer look at the high-level architecture, so this is actually a very common data pipeline pattern for us. From left to right, you can see that everything starts with files in our data lake. Those files are being processed by our Spark applications, which then write the output files to the intermediate storage, which is also S3 based. And then periodically, we load the processed data into our OLAP database, which is Druid, as I mentioned. So you probably all know that there are a few available cluster managers for Spark. We have Mesos, we have Yarn, we have Standalone, and the quite recently added Kubernetes. There are also options to run managed Spark versions on public clouds, such as AWS EMR, Databricks, of course, GCP Dataproc, etc. So if we focus on the data processing layer, we're actually leveraging AWS EMR to run our Spark clusters, and we use Yarn as our cluster manager. So what is EMR? EMR is basically an AWS managed service to run Hadoop and Spark clusters. it allows you to reduce costs by using spot instances, which are basically spare compute resources you can get for a significant discount from your cloud provider. And because it's a managed service, you also pay a management fee for every instance in the cluster. So let's see a pricing example. Say we have an EMR cluster that costs $1,000. Of that $1,000, we found that about $650 are what we pay for the machines. And of course, this is based on a specific instance type, which is, in our example, i3-8XL, and for the current spot pricing. This obviously can vary depending on the region, the instance type you're using, etc. But keeping this example, you can understand that there's still some more money to be paid. And those $350 is what we pay as the EMR fee. Now, this may seem a bit high, but since EMR is a fully managed service, you also get all the benefits from that being a service. Also, running Airflow-based Spark jobs on EMR is rather easy because EMR has official support in Airflow. So we have 3 components to run Spark applications from Airflow on EMR. The first one is the operator that basically creates new EMR clusters on demand. The second operator, which is called EMR add steps, basically add the Spark step to the cluster or submits that Spark application. And the last one is called a sensor, and it basically checks if the step succeeded or failed. Now, remember, Airflow is an open source project, so that allowed us to fix existing components, like this rather small fix that we did in the EMR step sensor. It also allowed us to contribute things that are not necessarily related to EMR, but rather related to our data pipelines in general. So for example, this AWS Athena sensor and the OpenFast hook, my colleagues contributed. So this was all great, but we wanted more. So we wanted to further reduce our costs. We wanted to have better visibility, and we wanted to make our systems more robust. And now Roy will explain how we were able to achieve all that.
Thanks, Itai. I'm going to talk with you about Spark-On-Kubernetes as the platform that helps us to achieve all of the things that Itai talked with you before. So let's do a quick recap on what Kubernetes is. So Kubernetes is an open source platform for running and managing containerized workloads, and it includes built-in controllers to support various workloads, such as microservices. And it also has additional extensions that called operator to support custom workloads, such as Spark, and it's highly scalable. Here we have a Kubernetes cluster. On this cluster, we have the pods. They are the application that running. They are a group of 1 or more containers, such as Docker containers, and they are running on the worker nodes, EC2 in our case. And every cluster also has a control plane. It's assigning the pods to the nodes and also provides other cluster management services. The kubectl is the Kubernetes CLI. With the kubectl, we can see which pods are running on the cluster and also launch new workloads. The term operator exists both in Airflow and in Kubernetes, but they are quite different. In Airflow, an operator represents a single task. The operator determines what is actually executed when your DAG runs. So for example, we have the bash operator that executes a bash command. On the other hand, we have the Kubernetes operator. It is an additional extension to Kubernetes, and it holds the knowledge of how to manage a specific application. For example, we have the Postgres operator that defines and manages a PostgreSQL cluster. So Airflow operator is not equal to Kubernetes operator. Another cool feature of Kubernetes is the cluster autoscaling. At this stage, we have a Kubernetes cluster without any pods running on it, and it doesn't have worker nodes either. When I'm launching a new pod, it gets the pending state, and the cluster is triggering the autoscaling, and new EC2 instance is joining the cluster, and my pod is running. When I launch another pod, it gets the pending state too. The cluster is triggering the autoscaling again, and another EC2 instance joining the cluster, and my 2 pods are running. When my pods finish working, the cluster scales in again, and now I'm paying only for the cluster management fee, which is very cheap, and at Amazon case, it's $60 per month. So Kubernetes in a nutshell is a platform for running and managing containerized workloads, and each cluster has one control plane, 0 to thousands of worker nodes, 0 to tens of thousands of applications running concurrently, a Kubernetes operator is not equal to Airflow operator, and the cluster can automatically scale out and in. Cool, so now we can start talking about Spark-On-Kubernetes. So from Spark version 2.3.0, Kubernetes is supported as a cluster manager. We are not paying any management fee per instance. We are paying only for the instances itself, and $60 per month for the cluster management fee at Amazon case, which is very cheap. This feature is still experimental, and some of the features are missing and not complete. For example, we have the dynamic resource allocation that is lacking, and external shuffle service is not implemented yet. How can we submit Spark application to Kubernetes? We have 2 alternatives. The first one is using the Spark submit script we all know, and the other alternative is by using the Spark-On-Kubernetes operator. Let's start with the Spark submit. So here, nothing really out of the ordinary, other than at the master argument, I'm giving it the Kubernetes API server address, and the Spark submit sending the Spark driver pod definition to the Kubernetes cluster, and now I have Spark driver pod running, and the driver is controlling the executors that it needs. On the other end, we have the Spark-On-Kubernetes operator, which is a Kubernetes operator, and it extends the Kubernetes API to support Spark applications natively. So now Kubernetes knows what Spark application is. And it's built by GCP as an open source project. You can see the link below. So with the Spark-On-Kubernetes operator, I'm writing my Spark application parameters and arguments as a Kubernetes object manifest with the type Spark application. Now I can send this manifest with kubectl, and the cluster gets it. We have the Spark-On-Kubernetes operator running on the cluster, and it's doing the Spark submit for us. And now we have the Spark driver pod running on the cluster. And again, the driver pod is controlling its own executors. Let's do a quick comparison of these 2 methods. With Spark submit, it has Airflow built-in integration, but it lacks the ability to customize Spark pods. It don't offer easy access to the Spark UI, and we can submit and view applications from kubectl. With the Spark-On-Kubernetes operator, it still don't have Airflow built-in integration, but it has the ability to customize Spark pods. It offers easy access to the Spark UI, and we can submit and view applications from kubectl. So we wanted to take all of the advantages of the Spark-On-Kubernetes operator with Airflow. So we need to integrate them too. So we decided to take the road less traveled and build an Airflow integration with the Spark-On-Kubernetes operator. So now you can send the Spark application with the Spark-On-Kubernetes operator from Airflow. After we build this integration, we contribute it back to the Airflow open source project, so you can use it too. A special thanks is deserved to all of the Airflow committers and community that helped us along the way and gave us a lot of valuable mentoring. So let's see how the Airflow Spark Kubernetes integration looks like. So it consists of 3 components, and the first one is the Spark Kubernetes operator, which is the Airflow operator, and it's sending the Spark application to the Kubernetes cluster. We also have the Spark Kubernetes sensor that pokes the Spark application and ends successfully if your Spark application ended with success, or fail if your Spark application failed. And we have the Kubernetes hook that helps Airflow to interact with the Kubernetes cluster. So what have we gained by building this integration? So first, now we can submit Spark application with the Spark-On-Kubernetes operator from Airflow. And it's built into the Airflow project, so it's official support. The second one is security. We are saving the Kubernetes credentials inside of the Airflow connection mechanism, which is encrypted. Also, portability. We are using the same templated Kubernetes object both when running from Airflow and both when we are running our application manually for debugging. And it's Kubernetes native. It communicates directly with the Kubernetes API. So thanks, and now back to you, Itai.
Thank you, Roy, for this great explanation of Spark on Kubernetes and on the Airflow integration you built. So going back to the common data pipeline pattern we started with, you can see the Airflow DAG here. And if we dig deeper into the architecture, you can see that basically this architecture hasn't changed much. The only thing that has seriously changed is the fact that in our data processing layer, we're now running Spark on Kubernetes. But something is still missing. So what is missing? So we had to connect the dots and make it production ready. Remember, I told you that we wanted to gain better visibility and robustness. So let's see what we've done with that. So in terms of visibility, what we have is a dedicated Spark history server for each Kubernetes namespace. That allows us to view the Spark UI for every running application in Spark or for applications that already completed. Of course, we needed metrics. So we send both Spark metrics that are exposed via JMXing and system metrics that are collected using this KubeState metrics plugin to Prometheus. On top of that, we build Grafana dashboards that aggregate both the Spark and the system metrics so we can see what's going on in our clusters in real time. So we are developers and we obviously need logs. And in order to investigate logs, we collect the logs using FileBit and send them to Elasticsearch. And nothing in a production environment is completed without alerting. So we use Airflow callbacks in order to emit metrics to our monitoring system. And then we can trigger alerts whenever needed based on the values of those metrics. I also promised you to talk about robustness. So here are 2 tips in this domain. The first one is you can actually run a Spark application on multiple availability zones. That can be very beneficial when using spot instances because it allows you to increase the availability of those instances and decrease the probability of losing instances mid-execution of your Spark application. This is very suitable when your Spark applications have low shuffle volume. The other thing is the AWS no termination handler. So it allows Kubernetes to gracefully handle events such as EC2 spot interruptions, and it can slightly increase the stability of your cluster. This is open source, so you can take a look at the Git repo here and install it on your cluster. So the benefits for migrating to Kubernetes are the same as we discussed or what we started with. So you can save about 30% in your costs because there's no additional cost per instance like we have in EMR. We saw that we can get better visibility and make our systems more robust using the tips I mentioned. As per the Airflow integration that Roy worked and contributed, then this will be available in the upcoming release of Airflow, which will be Airflow 2.0. Now, I'm sure many of you can't wait, so we suggest that you check out the backport package that's already available for Airflow 1.10.12. So basically, we've showed you that with minimal changes to your Airflow DAGs, you can boost your data pipeline like we did. So you can save a lot of money every month. You can gain visibility and make your systems more robust. So just before we wrap things up, a few things we care about. Women in Big Data is a worldwide program that aims to inspire, connect, grow, and champion the success of women in the big data and analytics field. There are over 30 chapters and over 17,000 members worldwide. Now, everyone can join regardless of gender, so we encourage you to find a chapter near you on the Women in Big Data website. We also have the Nielsen R&D Center Tech blog, where we write about the awesome things that we do. Specifically, during this migration process, Roy and I wrote a 2-part blog series about Spark dynamic partition inserts and how it behaves when you run Spark on EMR versus Spark on Kubernetes. Cool, that's it for us. We thank you for paying attention and for listening. You can reach us out on Twitter and LinkedIn, and we'll be taking questions now. Also, please don't forget to rate our session on the Data and AI Summit website. Thank you, everyone.